आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
In this episode, we are extremely happy to receive a conversation from Professor Achintya Singha. He will be introducing himself and will be sharing his academic journey.
I am Achintya Singha. I am a professor at Bose Institute, and my journey in science, especially experimental physics, began during my Bachelor's of Science in Physics at Minnapur College. After that, I completed my Master's in Physics from Jadavpur University and then pursued a PhD in Nanoscience at Indian Institute of Technology, Kharagpur, where I worked in laboratory of Professor Anushree Rai. In her lab, I learned a lot. Her guidance gave me confidence to build my own experimental physics lab from scratch and develop instruments. I gained expertise in Raman spectroscopy, a technique used to study nanomaterials at the molecular level. After my PhD, I moved to Italy for postdoctoral research at Scuola Normale Superiore, Pisa, in Dr. Vittorio Pellegrini's lab. There, I worked on understanding how electrons behave in nanostructures using light scattering and magnetotransport techniques. One of our major breakthroughs in exploring the Mott-Howard physics in nanofabricated materials and the work published in Science. After nearly 3 years in Italy, I returned to India and joined as a faculty at Bose Institute. I established a Raman spectroscopy lab and focused on studying nanomaterials, also known as quantum materials.
Professor Achintya Singha speaks on the core area of his research work in short.
My works involved developing these materials and exploring their application in energy storage, energy harvesting, and sensing technology. So my research aimed to engineer quantum materials, investigate their fundamental properties under external perturbation, valitronics, and explore their potential application in photodetection, light emission, energy harvesting, energy storage, and biosensing.
Professor Singha now explains in details.
I'd like to tell our audience a little bit about nanomaterials. Materials we see around us, such as metals, plastics, or glass, allow electrons to move freely in all directions. But in nanomaterials, at least one dimension is so small, just a few nanometers, that electrons behave differently due to quantum effect. These materials are classified into two-dimensional materials in which electrons can move freely in two directions but are confined in the third. In 1D materials, electrons can move in one direction. In zero-dimensional materials, electrons are confined in all three directions. Because of their small size, this material exhibit unique properties, making them essential for future technologies. By adjusting factors like size, temperature, pressure, magnetic field, and electric field, we can tune their behavior for specific applications. Understanding material behavior under these external influences is crucial for future device applications, and my group is involved in this area of research. One of the most exciting area we are working on is valectronics, a field beyond conventional electronics and spintronics. Traditional electronics devices use the charge of an electron for processing information, but this leads to problems like high power consumption and heat generation. Spintronics involved this by using the electron spin, making devices more efficient. Now, valectronics takes it a step further by using values, specific energy states in material to store and process information. Electronics can revolutionize quantum computing and data storage, making devices faster, more energy efficient, and more compact.
Professor Singha now shares his views on the direct application of his area of studies.
Our work has direct applications in various fields. High sensitive photodetector that work in visible and infrared light can be used as night vision camera, which enhances security and surveillance. Advanced energy storage devices can contribute to suitable energy sources. Ultra-sensitive molecular sensor can help in early detection of disease. And valectronics has the potential to transform classical and quantum computing, leading to faster and more efficient processing system.
Professor Achintya Singha now focuses on the significant progress of India in this area of research.
India is making significant progress in nanotechnology and quantum research. Government initiatives like the National Quantum Mission, National Mission, and Green Energy Mission are fostering innovation. With growing investment and global collaboration, India is on the path to becoming a leader in this field.
Professor Singha now speaks on the national and international contemporaries and collaborators in this research area.
I work with several international and national institutes. Some of my international collaborators, including Professor Justin Holmes from University College Cork, Ireland, Professor Francesco Mongiot from University of Geneva, Italy. And in India, I collaborate with esteemed scientists like Professor Indrani Bose, Professor Arup Kumar Raichaudhary, Professor Sumit Kumar Ray, and Professor Arindam Ghosh.
Professor Singha now shares his views on the real-world application of his studies.
As of now, we don't have direct industry collaboration, but we hope to establish industry partnership near future to bring our research into real-world applications. So, our research in nanomaterials and quantum technologies has the potential to shape the future, from better energy solution to cutting-edge computing and healthcare advancement. These innovations will play a crucial role in making technology smarter and more efficient for everyday life. I am excited about what lies ahead and look forward to more breakthroughs in this fascinating field.
We are extremely thankful to Professor Achintya Singha for his valuable speech. Thank you so much.